Very good morning, all of you. Welcome to Unified Study. Very good morning. How are you all? Fine. Yes. How are you all? How is the Josh? How is the Josh? Full Josh? Hi? Yes. So with full of motivation and full of dedication, we are going to start discrete math today. Yes, yes. Hi, hi, hi. Very good. Fine. Very good. Very good. Chalo. So here today, fully motivation. And what I told, never leave your dream for anything. Leave everything for your dream, but never leave your dream. Never, right? Yes. So it's your dream. You have to start learning. And tell me one thing. Say that today we are going to start graph theory. Graph theory is very, very easy. Tell yourself graph theory is very, very easy, very, very interesting. Graph theory is very easy and very interesting. I am going to start graph theory today and it will be one of my favorite subject. I will learn graph theory in depth and after that I can get a good score on graph theory also. Yes, yes. Wow, yes, I can see 100, near about 100 learners. It's showing 94 learners, those who wake up early and you join early in the class. That's more good. That's more good. 102 learners. Yes, 102 learners. Yes, this is Unified Study Rock. You all join and you all wake up, so you take your first step. You already took your first step in your life, that yes, you started early, you join early and you are ready to learn. So ready to learn, all of you. Great. So yes, it's me. Those who don't know about me, welcome to Unified Study and I am Priyanka Chatterjee, UGC NET qualified with 99.46 percentile on December 2019. After that I applied for TA set also last year and I got 190 mark score and there also I was in rank. And after that the 4 years online teaching experience I have. So from last 4 years I am teaching. Just after passing, when before passing only I had started this channel and I took experience from everywhere. And I have 5 years. Before that I have 5 years industry experience also. So I did my MCA and BSc Computer Science. So from this all experience I am going to guide you. From this all experience I am going to guide you. And our strategy is less is more. Yes. I will not provide you too much content so that you will be bored, but you will be happy. You will be very happy to learn it. Yes. So let's start. So first of all, here these are some handwritten notes, that is I am going to provide you. These are just my only whatever I have written in my handwritten note. From my handwritten notes, some of the topic I am telling you. After that I will go for you also. Why I am showing you handwritten notes? So that you can also prepare my handwritten note. Please don't bother about handwriting because it is my college note only. From my college note I took that. I did not prepare again another note for you. So it is my college note, from that only I took the screenshot. So please don't bother about the handwriting. Maybe my handwriting is not that much good and I am sorry for that. But my teaching will be fine for you. Okay. Yes, yes. So here in graph theory, first of all, graph theory is working on vertices and edges. Total graph theory will work on vertices and edges. Vertices means these are the vertices, that is all are the nodes, points. These are the vertices. And edges means when you are connecting the vertices. So graph, there are two types of graph, undirected graph and directed graph. Undirected graph means A to B, there is no connection. You can go to A to B also, you can go to B to A also. But directed graph means there should be a direction. You can move A to B, but you cannot come back B to A. That is the difference between directed graph and in undirected graph. If direction is given, then you have to write AB, you cannot write BA. But if the direction is not given, then AB is also correct, BA that is also correct. AB is also correct, BA is also correct. Okay, there will be no problem in AB or BA, whatever you are telling. So here a graph G is an ordered pair, that is VE, where V is the finite non-empty set. It should be non-empty, finite non-empty set, called the set of vertices. Yes. And E is the finite set, may be empty. Edge may not be there. If there is only one vertices, no edges, is it a graph? What you understand? If there is only one vertices, I draw here only one vertices. I hope you can see this is only one vertex is there. Only one vertex. Vertices not, only one vertex is there. Is this a graph? What do you think? Is this a graph? From this understanding, what is your understanding? If I am drawing one vertex here, is it a graph? Is this a graph? Yes, yes, this is also a graph, because this is also a graph. Wow, 153 learners. Really, I am so happy to see. Yes, all wake up early. 153 learners. That's good. Yes, this is also a graph, because graph means no not, it's yes. Yes, Naga Lakshmi, it is also a graph. What I told, that edge may be empty, vertices set cannot be empty, but edge may be empty. It is also a graph. No, it is not the pendant graph. This is not the pendant graph. I am telling you what is the definition of that. So here A, B, C, D is the vertices, and here are the edges you can see. These edges are called parallel edges. When you are drawing this type of edge, that is called parallel edges. And when I am drawing this type of edge, this is called loop. This is called loop. But we will work on simple graph. So simple graph is not accepting any parallel edge or the loop. Throughout our journey, we will learn the simple graph. So in the simple graph, if there are any parallel edge or there are any loop, we will remove that, and after that we will go ahead for the next step. But if the loop is there, then the degree, whenever we are counting the degree, for the loop, always we will count the degree as 2. Degree means what? Degree means that in a vertex, how many edges are connected. So if I am doing it is A, B, so for A degree is 1, for B also degree is 1. Because how many edges are connected? Only one edge is connected with A and B. A also there is one edge, B also there is one edge. That's why degree is 1 here. But if I am drawing like this loop, so for the loop we will count degree as 2, because the starting and ending of this edge is same. That's why for the loop degree will be always 2. Okay. But normally in simple graph, loop is not allowed. Must write down it, whatever some points I am going to tell you, must write it down in your notebook. Okay. Adjacent. What is adjacent? Adjacent means when two vertices are n vertex on edge, that is called the adjacent. Like same edges, that is called adjacent. They are adjacent. Adjacent vertex, adjacent edge, both can be there. Adjacent vertex means same edge they are connected. Adjacent edge means they are connected with the same vertices. ठीक है. This is parallel, this is loop. Incident. What is the meaning of incident? Degree, I told how many edges are there in a vertex. If I am telling there are 3 edges connected, I will say that here you can see I am counting the degree. Here we will count the degree. I am coming to the degree. Before that, here you can see the incident and adjacent. What is the meaning of incident and adjacent? Adjacent means when 2 vertices are n vertex of an edge join the same edge, that is called adjacent. Incident means the vertex V and n vertex of some edge E. Then V is said to be incident on. ठीक है. Now you can see the example of adjacent edges. What are the adjacent edges here? By example you can understand very clearly. You can see here 1 and 2 is connected through A, and that's why they are adjacent vertices. Adjacent edges, see that A, B both edges are connected through one vertex. That's why this is called adjacent edge. Adjacent vertex and edge is clear. Is this clear? But can we say 1, 3 is adjacent? No. Because 1 is here, 3 is here. They are not connected. That's why they are not adjacent. Can I say A and C? Can I say A and C they are connected? They are adjacent? No, because there is no connection with vertex. That's why they are not adjacent. So adjacent concept is clear, I hope so. Yes, clear. Very good everyone. All are super learners, super kid. All of you are super kid, right? Chalo. Simple graph. So neither parallel nor loop. In the simple graph there will be no parallel, no group, no loop. Isolated vertex. What is called isolated vertex? Isolated vertex means not the end vertex of any edge. It is not the end vertex of any edge. That's why it is called isolated vertex. Okay. So here if I am drawing a graph like this and here is a vertex. This is a graph, and in this graph here is a vertex that is not connected with anyone. This vertex is not connected with anyone. That's why this is called the isolated vertex. Got it? If I am giving this name A, B, C, D and E, A is the isolated vertex here. Pendant vertex. Pendant vertex means vertex of degree 1. If I am drawing a vertex here, that is E. E is the pendant vertex. Okay. Here E is the pendant vertex of degree 1. Here you can see the V5 is the pendant vertex. Got it? Degree of the vertex. Degree of the vertex means what I told, that the number of edges incident on the vertex. So tell me here what is the degree for B? How many edges are there? What is the degree? 1, 2, 3. 3 is the degree. Here what is the degree? 2. Here what is the degree? 2. Here also 2. Here degree is 0. Degree clear? Degree clear? So here what will be the degree? Here whenever I am connecting V1, that is degree 2. Here V2, whenever I am doing V2, then what will be the degree? Because as they are loop, here it is 1, 2, 3, 4 and 5. That's why degree is 5 here. Here what will be the degree for V3? V3 is 1 and 2. This is 2. That's why V3 is 3. V4 what will be the degree? Got it? Clear? V4, here is a V4, that is a isolated vertex, and that's why degree is 0. V5, what is the degree? That is 1. 1 is the degree here. That's why it is pendant vertex. Good. Clear? Yes. Now see that what is the total degree. Now we will see what is the total degree. Total degree is here. You can see 10. Right. 10 is the total degree here whenever I am doing 1 plus 5 plus 3 plus 1. That will be 11 actually. Here you can see the 11 because it is a pendant one. Because it is a pendant one, and that's why V2 is 4. Not 5. V2 is 5 because if you see V2 very clearly, V2 is like that. V2 is, there is a loop, there are a parallel edge, and here is another vertex. No. Very clearly see that. Here, try to, I am zooming it. Is this clear? See, here, wait. V2 is not 4, it's 5. Because why? See, very carefully see that. This is a loop, right? Here is a loop. And this is a parallel edge. This is the parallel. So for the loop degree is 2. For this one 1, 1, 2. And for this one 2. So what it is? 2 plus 1 plus 1 plus 1. That's why this is 5. That's why this will be 5. Is it or not? Got it? Got it? Why it is 5? Yes, that's why this is 5. V3, 2, 3, 4. V3 will be 4. Yes, V3 is 4. V3 will be 4. V3 will be 4 here. Yes. Got it? V3 is 4 because for the loop 2, here it is 1, 3 and here it is 1, 4. V3 is 4. ठीक है, clear, concept clear, concept clear to everyone, I hope so. Yes, V3 is 4, V3 is 4, V3 is 4 here. So that's why total will be here. If I am taking the V4, then V4, so here degree of V4 is 0 here. You can see already 0 I told here V4. So that's why 2 plus 5 plus 4 plus 0 plus 1. That is your total degree. This is your total degree. Yes. Now you can see here the G graph edge. Whenever, this is a very important algorithm, handshaking algorithm. Handshaking algorithm is the most important algorithm. Always remember that. As you know, here I took the loop also. Here we took the parallel edges also. But whenever we are working in simple graph, simple dimple, simple graph, okay. In a simple graph, always there will be no loop. That's why whenever I am drawing an edge, a edge will be connected with two vertices, right? For an edge, there will be two vertices always. So, as this is a edge E, for edge E, how many vertices are there? V1, V2, two vertices are there. For edge E, there are V1, V2, two vertices, right? So, for V1 also you are counting degree as 1. For V2 also you are counting degree as 1, right? So, what is the total degree here? For E, E is contributing the degree here also. E is contributing the degree here also. So, one edge is always contributing degree in a total degree. Total degree of the graph is what? The total degree of the graph is 1 plus 1, that is 2. But there is only one edge. So, for one edge, always it is contributing 2 times. Always it is contributing 2 times. That's why the total degree of the graph will be 2 multiply into E. Right. That's why the total degree of the vertex will be, that's why the total degree of the vertex will be 2 multiply into E. Clear? Is this clear to everyone? 2 multiply into E. Why? Why it is clear? Yes, yes. PDF I will upload in Unify Study app. You all can download the Unify Study app. I share the link also. You can go to Play Store. You can search Unify Study with the same logo. You can get it. So you can see that Unify Study by Priyanka ma'am with the same logo. You can download it and I will upload their PDF. Okay, you can go to the study material. You can see the PDF there. I will upload the PDF after the class. Okay, after the class I will upload the PDF. Maybe after completion of graph theory I will upload that. Okay, okay. So now see that here what it will be. Here always 2 multiply 2 times of the age, and that's why whenever you are multiplying anything 2 with any odd number, that is also even. 2 with any even number, that is also even. Is it or not? 2 you are multiplying with odd number, 2 you are multiplying with even number, always that will be even. That's why the total degree of the graph will be always even. Total degree of the graph will be always even, although it was coming odd. Why it was coming odd? Because it is not a simple graph. Here we took loop, here we took edges, so that's why it was not correct. That's why it was not coming correct, right? Yes. So here what it was coming 11. Is it possible? 7, 8 plus 12, that is 12. So 11 is not possible. It will be 12 definitely. In a graph it cannot be. It is not possible 11. It will be 12, right? So always in a graph it will be always in simple graph also, in loop also. Because that's why in a loop degree we are not taking as 1. That's why degree will be 2 here. Okay, ठीक है, ठीक है, clear, clear it is. Yes, it is asking for permission because it's trying to save in your mobile, right? So it will create a folder in your mobile under the app of Unify Study. That's why it is asking for permission. If you are not giving permission, how the PDF will be saved? That's why it is asking. If you want to save, then definitely it will ask you permission. If you don't want to save, then no need to permit permission, no need to provide permission. Okay, Preeti? ठीक है. Now see that for the handshaking algorithm, you can see sometimes they will provide you some example like that. If a 6 vertices of edge degree 3 is possible. Is it a correct graph? Never possible, because here it will be 15. Total 15, it's odd number. That's why this type of graph is never possible. 4 edge, 4 vertices having degree 1, 2, 3, 4. Is this possible? Is it a correct graph? Is it exist? Yes, you can see that total is 4. Here you can see 4 multiply 2, that will be 8. But 1 plus 2 plus 3 plus 4, when you are taking, that is 10. So is it possible? One side using handshaking algorithm, as there are total edge 4. So I can understand total degree will be 8. Right? But here it is given degree 1 plus 2 plus 3 plus 4, that is coming 10. How it is possible? One answer is coming 8, another answer is coming 10. That is a conflict, right? So this is not a graph. Sometimes they are asking question like this way also. A graph is given like that. Is it a correct graph or not? This type of graph is exist or not? So by handshaking algorithm, and from this concept you can say that this type of graph will be not possible. Got it? Got it? This type of question they are asking. I hope it is clear. Is this clear to everyone? Yes, yes. Chalo. Very good. 171 live learners. Before 6 a.m. only. It's 5:57 a.m. morning. Early morning. You all are studying. That's good. Very good attitude. I am so happy for that attitude. Very good. Very good. Okay. So here it is directed graph and undirected graph. Directed graph means the direction. You can see already I told the direction will be there. Here the direction is not there. No ordering, no direction. Okay. Now you can see the finite graph. What is the finite graph? Finite graph means here you can see the finite graph. Finite means it is countable, right? The graph with the finite number of vertices is called finite graph. Null graph means no edges, only vertices, no edges, okay? So that's why it is only vertices. Trivial graph. For the trivial graph, what you will be? The graph where vertex set contain only one vertex and edge set is empty. Here this is called trivial graph. Clear? Clear? Okay. Explain. Already I took the example. This is the example, Arun. Everything I am explaining with example. What example you want, Arun? What example you want? I am giving the example, right? This is a trivial graph. This is a null graph. I am telling you the example, right? Yes. Now see, any doubt you have? Anyone have? Arun, example. What example you are asking? Print out PDF. Those who need print out PDF, please WhatsApp me. I will see. If you need the print out PDF, I will see what I can do for you. Okay. So, example of trivial. This is trivial. Only one vertex. Trivial means only one vertex. See that only one vertex is here. That is trivial. A graph where vertex set contain only one vertex is there. That is trivial only. Okay. Only one vertex you can see. This is a only one vertex. That is a trivial one. Clear? This is the null. So many vertices but no edges. This is null vertex, null graph. Got it? Pendant graph is pendant edge. Pendant is not graph. Pendant is the edge. This is a pendant. You are taking pendant, right? We are wearing pendant, right? In your chain there is a pendant. Pendant means pendant is a vertex. This is called a pendant vertex. This will be a pendant vertex. Pendant is not a graph. Pendant is a vertex which degree 1. This vertex of degree 1, that is called pendant vertex. And these are the graph. It is a complete graph. For the graph, complete graph not means it is a example of graph and it is a example of vertex. Pendant is the vertex. Pendant is not the edge. Got it? Clear? Yes. Okay. Handshaking is that. Handshaking means 2 times you will multiply. Everyone please concentrate. Handshaking means total number of edge will be always 2 multiply into E. Whatever total edges are given to you, it will be always 2 multiply into E. That is your total degree. Total degree of the graph. Total degree of a graph is 2 multiply into number of edges. That is the handshaking algorithm. That is handshaking algorithm, and that's why through handshaking algorithm it is always the total degree will be always even. Total degree of a graph will be always even. It cannot be odd. As you can see here, it is coming odd. If there are 5 vertices given, every one degree 3, so total degree is coming 15. that is never possible. So this type of graph never exists. Here the total is coming, here as per the handshaking algorithm we are able to see 8. But if I am doing total, I am getting 10. So this type of graph will be never exist. Got it? I will provide you some question on this. We are going to solve the question also. ठीक है? Pendant graph, pendant vertices. Pendant is not the graph, pendant is a vertex. Pendant vertex in a graph we can say it is a pendant vertex. Okay, it is not a graph. Pendant is the vertex. In a graph, a vertex with degree 1, that is called pendant vertex. Okay? Clear? Clear? Chalo. Now the complete graph. What is called complete graph? A graph is said to be complete when, this is very very important. Complete means everyone is connected with remaining others. Each and every vertex is connected with n-1 vertices. ठीक है? n-1 vertices. This is called the complete graph. You can see if I am drawing this graph. Is this a complete graph? Is this a complete graph? This is not a complete graph, right? This is not a complete graph. Right? Everyone, please concentrate. Please concentrate. Subbu, ma'am, is the pendant graph? They are then degree 5. Not. You can see here you have a you have the problem. In the pendant graph, what is the degree? 2. Here it is 3. This is the 3. Here it is 2. Here it is 2. Here it is 1. So what is the total? 2 plus 2 plus 2 plus 3 plus 1. Is it even or not? Is it even or not? This is 6 plus 3, 9 plus 1, 10. Always it will be even. Got it? Who was asking that? Subbu. Subbu, ma'am, in pendant graph there is 5 degree. No, 5 is not the degree. Total degree. You have to count the total degree of the graph. Total degree of a graph is always even. That is the handshaking algorithm. It will be definitely even. It cannot be odd. You cannot draw any graph where it will be odd degree. You can try, you cannot draw. It's not possible. Here also there is a pendant vertex, but here degree will be 10. Definitely. Got it? Clear? Pendant is nothing. Pendant means if you are wearing a chain. This is a chain. Here is a small pendant. You are wearing like that, right? In Valentine's Day pendant. You are wearing Valentine's Day pendant like that. Yes, this is connected with one vertex. This is called pendant, nothing else. Don't be confused. Valentine's Day pendant. Yes. So this is connected with only one edge. That's why it is called pendant. Nothing else. If it is a graph, this vertex is connected with 1 degree. That's why this vertex is called the pendant vertex. Nothing else. Don't be confused. Clear? Cholo. Yes. Difference between trivial and isolated. Trivial graph. Isolated vertex. Don't be confused with the graph and vertex. Trivial is the complete property of a graph. Trivial is the property of a graph. In a graph, only one vertex is there. That is the complete. This is a property of a graph. That graph will be called as trivial graph. In a graph, there is now nothing. Nothing is there. Only one vertex is there. That's why it is called trivial. And what is called that isolated? Isolated means I am drawing a graph. This is a graph, but here is a vertex. That vertex is isolated from other vertex. V1, V2, V3 and V4, and here is V5. This V5 is the isolated vertex. This is isolated vertex. It is not the graph. It is a isolated vertex. The graph is total with V1, V2, V3, V4, V5. This is the total graph. In the total graph there is age 1, age 2, age 3 and age 4 also. Got it? So inside that the V5 is not connected with anyone. That's why V5 is the isolated vertex. Don't combine the both. Definition of graph is different. Definition of a vertex is different. The definition here, whatever definition I told, these are the definition of vertex. Pendant vertex, isolated vertex. These are the definition of the vertex. These are not the definition of graph. It is a property of vertex. It is not the property of graph. And these are graph. This is the total one. That is the finite graph, null graph, trivial graph. In that graph no other vertex, no other edge is there. Got it? Okay. Trivial, no vertex, no edges, only one vertex in a graph. That is the property of a graph. Clear? How can we say one vertex is there in a graph? For a graph we need vertex and edge. No, Deepa. In the first definition I told you. That's why I am telling you. Remember, in the first definition I told that edge may be empty. Got it? What is the definition of a graph? Graph is a graph G is the ordered pair of V and E, finite non-empty set of vertices, and edge is finite set may be empty. That's why this is a graph. Whenever I am telling this is a graph, in that graph this is called a trivial graph. This is a trivial graph because there is no edges, only one vertex. Got it? Edge is not mandatory for a graph. This is also a graph. I am drawing so many vertices. This is also a graph. Edge is not the mandatory part. Each and every point should be clear to you. That's why those who are coming to my class, I will clear each and every point to you and write down. Those who are searching for PDF and all that is I will provide. PDF you can get. But the important points, these important points, please write down in your notebook so that your concept will be clear and your understanding will be clear. Understanding should be clear, because basic concept is not clear, then you cannot do the others. Basic concept should be clear. Yes. Clear to everyone. 189. Oh, good. Make it 200. Make it 200. I am so happy. I am so happy that yes, I left my job. Now I am feeling happy that yes, I left my job. There too in my job there was hardly 30-40 students was coming. But 190, oh my god, oh super, 190 learners at morning class. So it's a perfect morning. It's a perfect morning for me. I can teach 190 learners together in live class. That is a perfect morning for me, really. 190, really. Make it 200, make it 200. So chalo, so I hope it is clear, right? Yes, now you can see the complete graph. Yes. So the complete graph is what? Here, is this a complete graph? No. Because here is this one, that is V1, V2, V3 and V4. There are 4 vertices. So in these 4 vertices, what will be happen? 4 vertices are connected with how many? Here 4 vertices are connected with here degree 2, here also degree 2, here also degree 2, here also degree 2. Because V2 is not connected with V4. V1 is not connected with V4. V2 is not connected with V3. If I am make connection between each other all, Whenever I am making connection with all, then it will be also 3, this will be also 3, this will be also 3, this will be also 3. Now this is the complete one. So every vertex will be connected with remaining n minus 1 vertices. That's why it is called complete graph. So what will be the total degree? There are n vertices. Every one is connected with n minus 1 vertices. And every time one edge is counting 2 times. This is also I am counting degree 1. This is also I am counting degree 1. For each and every edge we are counting degree 2 times. That is contributing in the total degree of the graph. That's why we will divide by 2. That's why we are dividing by 2. Got it? That is n minus n into n minus 1 by 2. Clear? Ma'am, null graph is there also a vertex, trivial graph and null graph. Null graph no vertex here. Null graph here no edges. So many vertices are there but no edge. 4 vertex, 5 vertex, 10 vertex, 100 vertex can be there. If I am drawing this type, this is also a null graph. No edge. A graph vertex set of non-empty but edge is empty. That is null. Trivial means only one. I have written everything. All the definition is very clear. And it's taught by my guru, Showman Nondi, my Gurudev. And he is now you can search Showman Nondi, the graph theory, one big person of graph theory. He is doing PhD in graph theory. He did PhD. He is a postdoctorate. ISI PhD. So he is my teacher, Kolkata ISI PhD, Showman Nondi, who taught me this concept, and I am very blessed that yes, sir taught me this graph theory when I was in BSc. So in graph theory, whatever is written, whatever I am going to teach, that is here, at least here, these are the concept I learned from my sir. So there will be no problem, and each and every definition is very clear. Okay, so one day maybe if I can connect, then I will arrange a session with sir. So I will introduce my sir with all of you. So graph theory, really I learn everything till now. Most of the topic of computer science I learned from him. He is my Gurudev. He is my Gurudev. So Showman Nondi, he is a teacher. He is postdoctorate ISI. Postdoctorate ISI graph theory. If you search graph theory Showman Nondi, you will see so many articles on graph theory. So you can understand. No problem will be here. Okay. ठीक है? Clear. Now clear. Concept is clear. चलो. So here that's why n into n minus 1. N into n minus 1. Clear? N into n minus 1 by 2. That will be the total number of a complete graph. This is the total number of a complete graph. N into n minus 1 by 2. Okay? Can I ask you a question? Are you ready to do the question now? Yes. Chalo. Now do this. No, all trivial graph are not null graph here. That you understand. Huh? Write down in the chat box. Null graph means there is no edge. Trivial graph means there is only one vertex. Difference between trivial and null is that trivial graph means only one vertex. In a null graph, multiple vertex can be there, but no edge. Trivial graph is not null graph. Null graph is not trivial graph. Every trivial graph you can say null graph. Yes. Every trivial graph you can say it is a null graph also, but every null graph is not trivial. That is correct. Okay. Yes, every trivial graph is a null graph. Yes, null graph may be vertex also. Who told that? Huh. So every trivial graph is the null graph, but every null graph is not the trivial graph. ठीक है, चलो null trivial you all are confused now. Clear? Every null graph, every trivial graph is null, but all null graph is not trivial. ठीक है, clear now? Yes, every trivial is null, but all null graph is not trivial, because in a trivial graph only one vertex is there, no edges is there. That's why it will be. I hope it's clear now. Chalo. Yes, so answers already answers are coming. A graph contain 21 edges and 3 vertices of degree 4 and all other vertices of degree 2. Find the total number of vertices. Already I am getting some answer from some of the students. So yes, 185 or make it 200. As 200 कर दो इसको, कर दो 200. First day, first class 200. Make it 200. Tell your friends, join so that it can be 200. Ask in the group. We will reach to a destination. Okay, answers are coming. Yes, answer will be what? Find the total degree of the vertices here. So the graph contains 21 edges and 3 vertices of 21 edges means what? 21 edges means 21 into 2, that is total degree will be 42. This is the total degree, that is confirmed. Now 3 vertices of degree 4, 3 vertices of degree 4 plus here all other vertices of degree 2. All other vertices of degree 2. So n multiply 2. I am taking all other vertices, maybe n or x. I am writing x. Okay, maybe this is x. All other are x number of vertices are there, that is 2. So here find the total vertices. Here very carefully, as they are asking find the total vertices, it's always better to take that, because otherwise maybe you will do mistake. Think about that. Total vertices equals to n. So means here all other vertices, here already given that 3 vertices. So I will write n minus 3 multiply, because total vertices is n. So already 3 vertices I count here. So all other means that is n minus 3. Otherwise maybe you can do mistake. So n minus 3 if I am doing, that is degree 2. Then the total is 42 here. Then here you can see the total is 42. So what will be happen? This is 12 plus. So what will be happen? This is 12 plus 2n minus 6. Is 42. Yes, that will be happen. 12 plus 2n minus 6 is 42. So 12 plus 2n equals to 42 plus 6. So from here you can see 2n equals to, actually here it is 48. 48 minus 12, that is coming what? That is coming 36. So 2n equals to 36, n equals to 36 by 2, that is 18. Here why I told you to take n minus 3. Here instead of n minus 3, if you are taking n multiply into 2, then high chance is there you will say the answer as 15. high chance you will say that answer is 15, but that will be wrong. If you are telling answer 15, that will be wrong, because here you have to do the total number of vertices. So that's why always be careful. Okay, ठीक है. चलो, now do this one. Now do this one. Yes, I can see all of you are correct here. 18, 18, 18. Those who told Nate, SK, Anu, Vavani, Kuna, Kuntal, Lopa, Kartika, NK, Prathiva, Bishupriya, Gurlin. Be right. What is your name? Bashanti, SHR, Murgan, Darpan. Full Darpan 42, that is wrong. Darpan, your answer is wrong. Full moon 18 correct, and Balamuru correct. ठीक है, चलो do this one. Do this one now. A simple graph with 35 edges, 4 vertices of degree 5. Do it, I am coming in 1 minute. I am coming. Do this. Answer. Why I am not getting answer? What happened? Okay, answer came now. Yes, good. All of you are giving answer. Very good, everyone. So a simple graph with 35 edges, 4 vertices of degree 5, 5 vertices of degree 4, 4 vertices of degree 3. Find the number of vertices of degree 2. So here 35 into 2, that will be 70. Total will be definitely 70. Now from here we will do 4 vertices of degree 5. Then plus here 5 vertices of degree 4. Here 5 vertices of degree 4. Plus here 4 vertices of degree 3. 4 vertices of degree 3. Find the number of vertices of degree 2. So you can take here x multiply into 2, that is 70. So yes, here you will get the answer 20 plus 20 plus 12 plus 2x, that is 70. So 2x equals to what? 70 minus 20, 20, 40, 50, 52 minus 52. So here you will get 2x equals to what? 2x equals to 18. So x equals to 9. So answer will be 9. Right, you are getting answer 9. All of you are correct. Very good. Everyone is doing correct. All are doing correct. Very good. Now tell me, what will be the answer for this? What will be the answer for this? Akshay correct. Akshay, Bhavani, Lakshmi, SK, Pratibha, Rajnikant, and Srinivasulu, Minachi, Gandhimati, and Karobi, NN, Lopa, Priyanka, Kuntal, Preeti, Anu, Be Right, Sarnalipsha, Kartika, Gurlin, Deepa, Chetan, you join, good. Darpan, Ranjan, Bija, Rani, Binitha, Mary, Vanita, Anu, Saranya, Murshida, Jashpreet, Deepa, Arun Kumar, Josh, SHR, Vishwapriya, KP, J Prakash, Amar, Minesh, Full Moon, Pulak, Deepa, Kaja, Pulak, Thari, Devi, Sapna, all are correct. Good. Achha, now the new answers are coming. Yes, all of you are giving correct answer. Those who are telling 8, they are correct. Yes. Ye graph has 24 edges and degree of each vertex is k. Then what will be the following possible number of vertices? Definitely 24 multiply into 2, that will be 48. So out of this only 48 can be divisible by 8. 48 can be divisible by 8. That's why your answer will be this one. ठीक है चलो. Yes, no need to extract from x. No, why? Here though it was asking the number of vertices with degree 2 only, so that's why I took x. Number of vertices of degree 2 is x, that's why. ठीक है. Yes, good, everyone is correct here. 8 is the correct answer. All of you are correct. 8 is the correct answer. Complement of a graph. Now we will see what is called complement of a graph. Complement of a simple graph G is a graph EMRS. What is that? Do focus on here. After that I will see what it is. Please comment it. I will see. Okay. So complement of a graph. What is complement of a graph? Complement of a graph is the simple graph G bar we can say on the same set of vertices as G, such as there will be an edge between two vertices U, V and G. So from the definition you will be confused. What is that? From the example it will be easy. You can see it is a complete graph, right? This one is a complete graph. Now you can see in the complete graph how many vertices are there? There are 4 vertices. So in this graph also we took same 4 vertices. In this graph also we took same 4 vertices. But what is the difference? Difference is there if you are combining both, if you are merging them. Think like that. This is a separate part, just like a jigsaw puzzle. Just like a jigsaw puzzle. You are thinking as a jigsaw puzzle. It is a part of another puzzle and this is a part of another puzzle. So if you are adding them together, whenever you are able to combine them together, then you are getting this complete structure. Right? If you are adding this together, then I am getting this complete structure. And that's why this is called the complement. The G bar is the complement of G. Here also you can see. Here this is a complete graph with 5 vertices. It is also, this is one part and this is another part, just like a jigsaw puzzle. If I am adding them together, then I am able to get the complete graph. That's why this graph is the complement of another graph. Is this clear? The complement of a graph. Is this clear to everyone? Complement of the graph. Ashfia, you join late. Wake up early, wake up early. You put my image on your DP, but you are not waking up early, then how you will be Priyanka ma'am? Huh? How we will be Priyanka ma'am? You have to join early, right? Is this clear? Yes, that's why now come to the definition. That's why this is the definition. Definition is also important. Complement of a simple graph G is the graph on the same set of vertices as G such that there will be an edge between two vertices UV in G complement if if means if and only if. If and only if, that is the meaning of if, right? So if there is no edge between UV in G, okay, ठीक है? Okay, good Ashpia. If you already completed, then practice it. Follow the practice. Clear to everyone? Yes, very good everyone. So here Vg equals to Vg bar, and that's why definitely Eg bar plus Eg will be Ekn, complete graph, because whenever I am adding them together, then I am getting a complete graph. As I am getting the complete graph, so what it will be? N into n minus n 1 by 2. N into n minus 1 by 2, that will be the complete graph, right? Yes. Clear? Yes. Chalo. Now do this. Test series we will start the mock test practice session after ending this syllabus. 31st October I will end the syllabus, and from the month of November we will start the practice series, only practice. Here learn everything, then we will practice. Do this one. Now tell me this question. What will be the answer of this question? You will do this question here, and those two will be your home task. This is your home task. This is also your home task. Okay. Now we will solve this one. Try to solve this one, and these two will be your home task. What will be the answer for this? Consider a simple graph EG equals to 30, EG bar equals to 36, VG equals to what? What will be the number of vertices? Halopa giving answer, Srinivashulu giving answer. I need answer from everyone. Everyone should give the answer. Anu, full moon. Okay, Minachi, Pratibha, 12. Acha. Everyone is giving answer now. So, as there is given that C it is 30 and this is 36. If I am adding them together, then what it is coming? What will be this? If I am adding them together, then that is coming 72. Yes. So that's why here whenever you are adding them together, 36 plus this, that will become 66. Right. As it is coming 66. Now n into n minus 1 by 2 equals to 66. Now you have to put into the formula n into n minus 1 by 2. If you are putting into this formula, then you are getting this answer. Then you will get the answer 132. Here if you are doing 132 minus n is coming minus 11, but this will be 12, right? So that's why minus negative though not possible, negative will be not possible. So here your answer will be 12. Clear? Is this clear to everyone? Yes, 66, not 72. Sorry, it was coming 66. So that's why your answer will be this one. Yes, I hope it is clear to everyone how to solve. Yes, good, good. So without checking the answer, please do it as a home task. Without checking answer, must do it so that your concept will be clear. Ekalabya school, that is okay. Same, I think syllabus, if whatever check the syllabus, in the syllabus if it is there, then so definitely it will be. Am I visible? I am visible, right? Okay. So here you can see this is a component. This is another component. And this is also another component. These are the three components here. So in this graph, how many components are there? There are three components. Component means those who are not connected. You are able to make them separate. If you are able to make them separate, when subgraph, you are making the subgraph between them, that is called the component. In graph theory, component is the undirected graph where induce the subgraph any two vertices are not connected with each other in the path, that is called you component. Okay, so component is clear, I hope so. So now we will do little bit high level question. Little bit high level question. This is a next level question. So can you try this question? I will help you. I will help you. Try to think. This is a GATE previous year's question. Okay. Because low level question also we have to do. High level question also we have to do. This is a GATE previous year's question. And for this question you need to know, just understand the question. I will help you to understand, but I will tell you that try to think. Whenever you are trying to think, then your understanding will be more clear. Okay, so what is the question? You can see, let G be the graph with 100 factorial vertices with each vertex labeled by a distinct permutation. Think it, think it. I will explain now only. Okay. Shivraj, Shivaranjani. Yes, Shivaranjani, Shivraj. Hi. This is our last question for today. We will solve it now. We will solve it now only. But you will try. First try by yourself, then you can. 100 vertices with each vertex label 100 factorial. Okay, this is 100 factorial. This is not 100 vertex. This is 100 factorial. By a distinct permutation of number 1 to 100. There is an edge between vertices U and V. If and only if the label of U can be obtained by swapping two adjacent number in the label V. Let Y denote the degree of vertex in G and Z denote the number of connected component in G. Then Y plus 10Z equals to what? Then Y plus 10J equals to what? Okay, that is your question. Try to solve it. Good morning. Good morning, Vashvaraj. It's too late. We already start at 5:30. We are going to end the class and you are late. And those who are watching the class till now, I can see 10 likes. Only 10 likes. Can you please click on like or dislike? If you like this class, then you can like. If you dislike the class, you can dislike also. I can see only 20 like till now. So if you dislike, you can click on dislike, but at least any of them do it. Either like or dislike, whatever you want, you can do it here. Try it. I will explain this. Try this one. After that, I will explain. $150 students are watching. 150 students are watching, but for my end, okay. 150 students are watching here now. I am so happy. Chalo. What is the answer for this? Do it. I am waiting. Do it. I am waiting for you. Do it. Try it. After that, I will explain. Try to think. Explore your mind. Step by step we will go. Small, easy, then difficult. Every day you will understand concept. I will ask you question, and I will ask you some low level question also, some high level question also. Everything will be together. Come to class every day. You will understand how the class will be going on. Answers are coming. So many answers are coming. Some of the students are telling 119. Some of the two students are telling 109. So what is the answer? Achha, 109, 119. Achha, let me see. Let me explain you what it will be. See that here it is given 100 factorial. Whenever a big value is given to you, don't try with big value. What you can try? You can try with a small value, like take some example of 2 factorial, 3 factorial, and try to think about the question. Okay, because when you are trying to solve with a small value, then you will be able to understand what is going on here. Then you can put that concept in 100 factorial. That will be easy for you. So what we can see, if I am taking 3 factorial here. 3 factorial means what? Here it is given 100 factorial. Number of vertices is 1 to 100. So if I am taking 3 factorial, then what will be the vertices? 1, 2 and 3. Right? So that's why number of vertices is here 1, 2, 3. Okay. And here total 100 factorial. 3 factorial means 1 into 2 into 3. That is total 6 vertices are there. From the question only I can understand total 6 vertices are there. Right. Now there is an edge between vertex UV if and only if the label U are obtained by swapping the 2 adjacent number in the label. Okay. So the numbering of the vertices are like that. These are the numbering. Here if you are thinking like for example it is a graph. Here the numbering is 1, 2, 3. Here the numbering is 1, 3, 2. Here the number is 1, 2. Here the numbering is like that. 2, 3, 1. Here it is 2, 1, 3. Here it is maybe 3, 1, 2. Here it is 3, 2, 1. These are the 6 vertices are here, right? These are the number, means this is the name of the vertex. This is the name of the vertex. What is the name? This is the name of the vertex, you can see. Okay, the name of the vertex are this. Now you can see where are they are connected, how they are connected. When you are able to get the swapping between the number, then only they are connected. So 1, 2, 3 will be connected with what? Swapping between the number. 1, 2, 3 means 1, 3, 2 they are connected. 1 and 2. 2, 1, 3. 2, 1, 3 that will be also connected. 2, 1, 3 they are also connected. Same way, because 1, 2, 3 by swapping two adjacent. By swapping two adjacent, what are the number you are getting here? If you are swapping 2 and 1, then you will get 2, 1, 3. If you are swapping 2 and 3, then you will get 1, 3, 2. These are the two vertices number you are getting by swapping two adjacent. This is only the possibility. 1, 2, 3 will be connected with two vertex by swapping two adjacent number, that is 2, 1, 3 and 1, 3, 2. Is this or not? Yes or no? If I am swapping, write down, understand this line very carefully. Edge between the vertex U and B, if and only if label of U can be obtained by swapping two adjacent number in the label. So I am swapping two adjacent number. So 1, 2, 3 will be connected with 2, 1, 3 and 1, 3, 2. Yes. So that's why it is connected with 1, 3, 2 and 2, 1, 3. Same way, 1, 3, 2 will be connected with what? 1, 3, 2 will be connected with 3, 1, 2. It will be connected with 3, 1, 2 by swapping. And 1, 2, 3. 1, 2, 3 already connected. Yes. 2, 3, 1 will be connected with what? 3, 2, 1. 3, 2, 1. It will be connected with this one. And another one, what it will be? 2, 1, 3. It will be connected with this one also. Is it or not? Because 2 is there, 2, 1, 3. That will be connected with this one. 2, 1, 3 will be connected with, already I did 2, 1, 3. So 1, 2, 3 is also there. 3, 1, 2 will be connected with 1, 3, 2 and 3, 2, 1. So 3, 2, 1. Right. Yes. Is this clear? Are you getting? Is this clear? Right? They are connected like this way. That is, the question is saying that they are connected like this way. It is very clear. If I am taking, now you can see that yes, they are connected. 3 factorial means 1, 2, 3. It will be 2, 1, 3 and 1, 3, 2. If I am taking 4 factorial, then 1, 2, 3, 4. They will be connected with this 3. If I am taking 5 factorial, then by 4 swapping, so degree will be 4. Here you saw that every 1 degree is 2. Here also degree 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 2. Right? Yes. 1, 3, 2. 1, 3, 2. Chetan. 2, 1, 3. No. Adjacent swapping. 2 cannot be adjacent. 1 and 3 are adjacent. That's why you can swap 1 and 3. 3, 1, 2. 3 and 2 is adjacent. That's why you can swap 3 and 2. That is 1, 2, 3. Adjacent. Read the question. Edge between the adjacent one. Whenever they are adjacent. Two vertices by swapping the adjacent. This is the adjacent number. Okay. That's why you cannot take here, if you are taking 2, 1, 3, that is not correct. Because 2 is here, 1 is here. That cannot be adjacent. Okay. Here 1 and 3 are adjacent and 3 and 2 is adjacent. So whenever you are taking this number, always possibility will be. No, Bishwapriya, I told that already. 1, 2, 3, you cannot write 3 to 1. Because 3 is here, 1 is here. Right. So you can swap between 2 and 3. You can swap between 1 and 2. 1 and 3, they are not adjacent. They are adjacent. 1 and 3, between 1 and 3, 2 is present. Adjacent means those who are pair. Those who are close. What is adjacent? Which number are close? Between 1 and 3, so 2 is present. So you cannot swap 1 and 3. That is not allowed. 1 and 3 you cannot swap according to the question. In the question it is given, right? that we can swap between two adjacent number. Only adjacent number you can swap. In between you cannot swap. That is the question only. Right? So by swapping it is only possibility. This is possibility only by swapping 213 and 132. Here also by swapping I can get 2134 and 1324. Here also by swapping I can get 1243. No other than that. So always whenever 3 factorial degree will be 2. Whenever 4 factorial degree will be 3. Whenever 5 factorial degree will be 4. So whenever 100 factorial definitely degree will be 99. 99 swapping will be possible. Definitely 99 will be the degree. So the degree will be here 99. Now I got the degree. Yes. So you can see the connection of 3 factorial. When I did the 3 factorial, then it will be like a connection. And as they are connected, how many components are there? It will be always one component. Because disconnected, you will not get anyone disconnected. Everyone is connected with n-1 here. N- complete not, it is not a complete graph, but component will be only one. Always component will be only one. So you are getting only one component. Every time you will get only one component. Right? No disconnection. You are not able to make them. So degree is 99. Component is 1. Here it was given y plus 10z. You have to do y plus 10z. Y was given what? Y denotes the degree of the vertices. So y equals to 99. Z denotes the connection of the component. So z is one component. Okay. So what will be y plus 10z? 99 plus 10, that is 109. So that's why your answer will be 109. I hope it is clear to everyone. Clear, full clear. Yes. So how was the class? How was the class? After the class you can come back here whenever you will watch recording, or after the ending the class you can come back once in the link again, and in the comment section, not in the live chat, in the comment section please put your comment, all of you. I am very thankful to all of you that you came here. Really now I am so happy. Yes, after leaving my job I was thinking that I took a good decision or not. It was a definitely you can understand ki when someone is getting a good salary and leaving the job is not a easy task, right? But I left the job because really unified study is my dream. I want to teach you all. I want to connect with you all. Everywhere I want to connect with you all. And when I was doing my BSc computer science, when I go to my college, I went to my college. That time I am from a village. It is a very narrow area, and there is that much communication is not there. So what happened to me in my BSc, in my college, there was no teacher for computer science. When I took admission, there was no teacher for computer science, and I used to travel Saturday, every Saturday I used to travel 3 hours journey by bus. 3 hours, sometimes it was taking 4 hours also. 3 hours journey by bus I used to travel. I used to go to that place to learn from my sir Showman Nundi. So he was available on that college that time. So for tuition class only, every Saturday it was my task to go to that place by traveling 3 hours journey. I used to take tuition there Saturday night and Sunday morning also. Then after that I used to come back, and there again Sunday there was another tuition for math. I was to take that math tuition, and then I came back to home. That was my full BSc journey. BSc computer science journey was like that, because there was no available teacher, and that time in YouTube there was nothing availability. So I feel, I understand that how much pathetic when there is no source to understand, because that was first time when I started computer science. That was in 2004. I did my BSc in 2004. So it was a pathetic journey for me, and I was the first batch, and there from that first batch only 2 candidates pass the honors, BSc computer science honors. Only 2 candidates. I am the girl, another one boy was there in my college. So from that time only I was thinking that if I am able to provide where everyone is not able to understand, everyone need the education, so then I will try to help. Because of that motivation, really I started Unified Study. I think it is required. Yes, money is also required. At the end of the day, definitely money is required. Maybe after some time I will also go for some paid course, but I will try to provide the paid course as a affordable cost, and definitely regularly free classes will be here. I will continue the free classes, because I can understand how much pathetic this journey was. Whatever I learned from my sir, and after that I got so many good teacher. I collected lots of things at the journey of my UGC NET. There also I learned so many things. So now I have knowledge. After doing lots of struggle. So I want to share that to all of you, and share this video, share this link, share this Unified Study channel to all of your friends, because really I am now totally jobless. Totally I am investing for Unified Study, and I have decided I will not go for any other job. Whatever I will do, I want to do here. So if I got your support, if you are supporting me with all of your support, I hope it will be possible. If you are supporting me, then maybe I can prepare a proper virtual classroom like that, digital board and all. So with your support only I can do. PDF I will upload in app. You can go to Unified Study app. You can download the app from the Play Store. It is available in the Play Store. And here the community. Here in the community you can check. Here for the paper 1 I started a poll. You can participate on the poll for the paper 1 class. When you need that paper 1 class timing, please participate on the poll here, and go to Play Store, search Unified Study. You can get it. You will be able to get it. Here I will upload the PDF. PDF will be free of cost. I will provide you free PDF for today's class. No problem. You can download this PDF. Download from Play Store, and whenever you are downloading from Play Store, please put some rating and review and comment after using the app. Okay, thank you. See you again at evening 6:45 PM for software engineering. Evening 6:45 PM class will be there for software engineering, and tomorrow we will start here spanning tree. Tomorrow morning there will be graph 3 class again. Okay, tomorrow morning graph 3 class will be there. Bye everyone. Have a good day. Bye.